Okay, lecture E10, composite materials, close to the polymers, which we saw before. Layout, as usual, introduction, then talking about modern composites, manufacturing composites, and application of composites with the focus of facades. Introduction, composite materials are made out of a combination of two materials, often the ones which have very different properties. The materials work together, and by this they reinforce, that's composite, they reinforce themselves to be able to deal with the requested performance as it is expected, dissolved in one and another. Natural composites are found in animals, plants. Wood is, for example, a natural composite. It's made out of fiber, wood fibers, and the lignin, which laminates or keeps together the fibers, the cellulose fibers, to create the wood as a material. So these two weak materials don't achieve much by its own, but then combined, they form a strong natural material. That's what composites are as a system. Early composites are used for centuries. A nice sample which we always use in this environment is mud bricks, good for compressive, poor for tension, combined with straw or hair by horses, for example, good for tension, but poor for compression. And by combining these, the composite creates its power. Concrete, that's what you're aware of as well, is a composite as well, being combined of concrete, cement, concrete, and steel to deal with the reinforcement in the composite. The setup of such a composite, we have, for example, the fibers, which we see far left at the top. They provide a certain strength, a certain tensile strength. They are combined with a matrix. That's how the wrapping is called, or the matrix, which is the middle one. This organizes the transfer of forces from the one fiber to the other fiber to make sure that they are able to deal with, say, different influences of forces, and then the whole thing is combined, as we see here, into a composite as a total setting. Modern lightweight composites, fiber reinforced polymers. Fiber reinforced polymers are a typical modern used composite, and they're used by resin, epoxide or polyester are very common resins. And then as material, as reinforced material, carbon, glass, aramid, polymers, natural fibers, which are used as the stress-taking part of this of the composite. We do have various ways of dealing with this. We have the long fiber composite, which is the top left one. The typical concrete structure would be a long fiber with the long steel reinforcements, and you then position the reinforcement where you need it. We do have the short fiber composites. That's what we see when we go for concrete, for example. We have the short fiber steel. Reinforced concrete can do that the same with polymers. As composites, downside of the short fiber is they can't take stress loads that well because they have to transfer from the one fiber to the next, to the next, to the next stress, while the long fibers can deal with these forces a lot better. Positive part of short fiber versus long fiber, you easily can shape as you need it. You may add into flakes or particular particles to create a less dense structure and to, say, reduce the amount of material you need in the composite. How are they made? We mainly define open and closed molding setups. The open molding setups, the hand layered is the most common and the most simple one which we use. We have a mold. We add the fiber into the mold. We add the resin into the mold. We need to make sure that, say, air bubbles are somehow under control. We come to that later with the vacuum. And by that, we create our form. Instead of having this hand-laid setup, you can do the sprayed layer setup. Sprayed means that you have to have short fibers, which then, with the spray pistol, could be brought in position with air pressure. And by that, you're able to, say, easier create free forms, but downside, the short fibers, as I expressed it. And then we have the fiber winding. This one, the fiber winding. There, the fiber itself is on a roll, brought into this pot of resin, then being wet of resin, being woven around a structure to create a certain surface. This is the hand layer setup. You see the mold, you see all the hands, and you see the resin and the yellow pot at the top, which is brought on top of the fiber reinforcement. A result of this is how well these looks. And you also see it's a student project. It's simple to be made. It can be used easily and applied easily. Closed molding. We have 4 types of closed moldings. The resin transfer molding, which means we have a mold which is entirely locked, and then the resin is brought into this mold. Air needs to be able to leave the mold, and then the resin hardens in the mold, and then you can use the component, versus the centrifugal casting, which means it's a huge rotating tube, and then the fiber is brought in position, brought into the tube. By the rotating, it finds its surface. Normally tanks are done by this to make them, say, light, but also precise qua surface. And then you come to the vacuum bag molding, the mold, the brought in position, the fiber and the resin brought in position, the whole thing being evacuated, and by that securing that air is limited in the setup, in the result, and that you have a very sharp and precise surface. Yachts, modern sailing yachts, are mainly done with this technology. And then the compressing mold, the laminate is pressed together under intensive pressure, as it is said here, in the mold to create the shape as it is wanted. Application: lightweight, high strength, so very specialized and very, oriented structures, which we can imagine. This is space boxes, glass fiber reinforced plastic at TU Delft. You see the shape, you see also the molding shape to allow that the molded part really can taken out of the object. It's an GFRP surface with some insulation and a sandwich structure, or this one, a GFRP with coating and outer surface coating. Quite similar technology to the yacht technology, having a mold, then having all the GFRP brought in position, evacuating the whole thing to create this very nice, very smooth, and very complete shape. And by this, I stop this lecture. Again, it's a project of the Delft Darmstadt Munich Facade Education Project with all the partners who participated in it. Thanks, and end of this one.